In the last part of this video, I said I was going to give you a step-by-step example of creating a scatter plot, but just to get my content out a little bit sooner, what I'm going to do instead is give you an example you could work out on your own, just for practice, and roughly a week from now, I'll send another video showing you what your work should look like, so you can compare what you did to my work. And this is just optional if you want to do it for practice. And the main purpose of this video actually wasn't to show you how to put the dots onto a scatter plot, but to give you an idea of how a correlational study takes place in psychology, or what actually happens in a true correlational study. So a correlational study is non-experimental, and in a correlational study, what's typically done is a researcher gives a self-report questionnaire and asks the participants a series of questions, and then the researcher takes that data and uses the data to calculate several different correlations within the same study. So in a correlational study, a researcher doesn't calculate just one correlation. A researcher calculates several correlations and presents them at the same time in the article. That's because um, one correlation doesn't give you enough information to interpret. Um, it's very difficult to just interpret one correlation on its own because it could be interpreted in several different ways. So that's why a researcher calculates several different correlations, just so that the researcher can have puzzle pieces to fit together in his or her conclusion. So here I have a scenario, an imaginary scenario. We have a population, and a researcher takes a sample of that population to get participants. And the sample in a correlational study might be random, or it might be non-random. And what's more common in psychology is to use a non-random sample, like a convenient sample, and then just to admit that the non-random sample is a weakness of the study in the discussion section of the article. Non-random sampling, random sampling isn't common in psychology. It is done sometimes, but it's not common because it's just much more difficult to do and or possibly costly. So in a correlational study, you could have a random sample or you could have a non-random sample, but what you never have in a correlational study is random assignment because correlational study is not experimental. Like I said, it's a type of survey research, and there's no need to put people into different conditions. Everyone takes in a correlational study, everyone takes the same survey. So in this situation, in this correlational study, the participants are taking a survey on how much time they spend on social media, how often they compare themselves to others on social media, and their self-esteem. All of these variables are being measured with the survey, and the data is being recorded over here in a spreadsheet. So here we have the number of hours that a person spends on social media per week. Here we have the number of social comparisons that a person makes on social media, and maybe per day or maybe per week. It could be either one. Um, and here we have self-esteem. Let's imagine that self-esteem is on a 20-point scale, in which 1 is the lowest level of self-esteem and 20 is the highest. Um, so I know that a particular survey question would never be on a 20-point scale, but if the researcher was giving out a self-esteem inventory and the researcher was adding up participants' answers to the individual questions, the total score might go up to 20. So that's why I'm saying that the total self-esteem score could let's say range from 1 to 20 hypothetically. And here we have the data from all 10 people. Um, what a researcher could do is create a scatter plot for each possible correlation. So a researcher could create one scatter plot for hours on social media and number of social comparisons, and one variable would be on the x and the other one on the y. Um, Visually speaking, it actually doesn't matter which one goes on x and which one goes on y because you'll still see the same correlation either way. So if it's positive one way, it'll be positive. if it's let's say if it turns out to be a positive correlation with hours on X and comparisons on Y, um, it'll still come out. It'll still be positive if you flip them around. So it's not going to affect the trend that you end up seeing in the scatter plot. So this one right here, this first scatter plot would be hours and comparisons. Then the researcher could take the data for hours and the data for self-esteem, columns 1 and 3, and plot them on the second scatter plot. And so one variable would be on X and one would be on Y again. And the two variables, like I said, are hours and self-esteem. Then a researcher could make a scatter plot for the third possible correlation, which is comparisons and self-esteem. And this third scatter plot would show columns 2 and 3, basically. And then if a researcher did this, the researcher would be showing all possible correlations between the variables that were measured. And this is actually what a researcher typically does in a true correlational study. A researcher looks at all possible correlations between the measured variables just to get the most complete information possible. So what I'm showing you here is actually realistic. It's actually what would happen in a true correlational study. And I mentioned how when a researcher does a correlational study, the researcher will almost never show a scatter plot in an article. Instead, the researcher just shows a table of correlation coefficients. So if this was a correlational study in psychology, what the researcher would do is calculate all three possible correlations, and then and each correlation would have its own correlation coefficient. And then the researcher would just report those three correlation coefficients. So the researcher would calculate a correlation coefficient for hours and comparisons, another correlation coefficient for hours and self-esteem, and a third correlation coefficient for comparisons and self-esteem, and then report those three correlations in a table, and that would be the correlational study. So if you know how to calculate a correlation coefficient, you could also go ahead and try to calculate these three correlation coefficients, but that's not something I'm requiring from you at this point in time. And well, if you're doing a survey study in this class, then at some point you will be calculating correlations, and I'll show you how to do it at that point in time. And I also wanted to mention that if I ever ask you to create scatter plots as part of an activity, or to calculate correlation coefficients as part of an activity, then I'll provide a separate video with directions targeted toward that specific activity, since I didn't do a hands-on example here. And in the next part of the video, I'm going to go over exactly why a correlational study is low in internal validity, why a correlational study doesn't lead to a solid cause and effect, or a confident cause and effect conclusion.